Okay, so the fourth section of the week six lecture is going to be about the design for the environment or the DFE. So we start with the design for the environment. Just to give you a hint about that, is about the process of selecting the best method of manufacturing or selecting all the material or the life cycle assessment for the product that will be have the less impact on the environment from the beginning of the selecting of the material up to the end of the life in the recycling process. So we go through the design for the environment as a definition is a method to minimize or eliminate the environmental impacts actually of the product over its life cycle. The DFE strategy aims to improve the technology and the design tactics to expand the scope of the products. The key focus of the DFE is to minimize the environmental economic cost to the consumer while still focusing on the life cycle framework of the product. The effective DFE practice maintain or improves the product quality and the cost while reducing the environmental impacts. The DFE expand the traditional manufacturers' focus on the production and distribution of the products to a closed loop life cycle. So the DFE can be simply about the material use, the energy efficiency, and the waste avoidance. So the DFE practices are first, design for environmental processing and manufacturing, design for environmental packaging, design for the disposal or reuse, and design for the energy efficiency. The life cycle assessment is employed to forecast the impacts of different production alternatives of the products in a question, thus being able to choose the most environmentally friendly process. The Design for the Environmental Program, or DFE, is a United States Environmental Protection Agency program created in 1992. Additional reading can be Design for the Environment, A Guide to a Sustainable Product Development, second edition by Joseph Fixel. So the interrelationship between DFE practices can be explained in this chart. So in this flow chart, you can see that we have the design for the energy and the material conservation. The A2 is going to be designed for the source reduction. The B1 is going to be designed for the release reduction. The C1 is going to be designed for the product recovery. The C2 is designed for the product disassembly. And the C3 is going to be designed for the recyclability. So, for example, each one of these sections is going to be linked to the others by a way or another. Like, for example, the A1 is going to be about the use of recycled input and the reduce of the resources intensity. So the use of recycled input can be simply linked to design for the product recovery by choosing a reusable component. So we can simply use the recycled one in the design for the energy and the material conservation. And this is simply going to be linked to the simplified component interface. And this will be a part of the product simplicity, which is going to be a part of the design for the product disassembly. Again, if I can take another example, which is reducing the packaging, and this will be about reusable packaging to be designed. So I can simply using, for example, the same let's say plastic bag for multiple cases, like what you do in the case of the shopping. When you do shopping, you're using reusable bags. Minimize the waste, and this can be done by reducing the packaging, of course, and the byproduct synergy to be used in the design for the recyclability. The waste homogeneity is going to be about the avoid of the contaminants, eliminate the toxic, and avoid the adhesives. So every part is going to be linked with the other by multiple interrelationship for these practices. Now, the environmental design for the environment guidelines is going to be mainly linked to four main parts. What's going to be the first one, design for the dematerialization. That will be the first part. Second part is going to be designed for the detoxification, and the C part is going to be designed for the liberalizations, which is going to be about the redevelopment. And we go for the last part, which is going to be designed for the capital protection and renewable. So you can see that for the A1 is going to be about design for the energy and the material conservation. It's all about the material. Design for the source reduction and design for the certifications. So each part is going to be linked with a multiple tasks. The second part is going to be designed for the detoxifications, which is about design for the release reduction, the design for the hazard reduction, and design for the binning waste distributions. So the distributions. Okay, so the C part is going to be about the design for the product recovery and design for the product disassembly and design for the recyclability. That's how we can simply do a redevelopment for the design so it can be recycled and or reuse or whatever the part is. Now for the part D is going to design for the human capital, design for the natural capital, and design for the economical capital. So let's see about the product life cycle in general. We're going to extract the material. And this will come, of course, from resources. So we're going to use either renewable resources or it's going to be non-renewable resources. Like, for example, most of the polymers are non-renewable resources. So that first part is coming from the natural biological life cycle. Part of the natural decay to make the resources can become from deposits. Some of the organic material can be deposits, and the inorganics and the toxic materials cannot be actually deposits. So the natural decay always going to be heaven for something like the wood, if you can leave for a long time. The glass never, the plastic never, but the glass can be recycled, so it shouldn't be something hard to actually be used. Now, when we're going to get the materials, we're going to have the production to be done. Some of the post-industrial recycling should be replied. For example, we're going to do the casting, the created part can be recycled and reused as a new material. After the production, we can actually, sorry, it's going to be production. We can do remanufacturing process. We're going to go for distribution, the use, the recovery. Some of the parts can be reused, and some of the parts will go as a waste, and the others can be a post-consumer recycling and used as an additive to the new material for the manufacturing process. And this will be about the product industrial life cycle part. Example of the disassembly tree for the electronic products. We're going to talk about receive the product, reuse it as it is, refresh, disassemble, shred and recycle, or dispose it as a waste. So you have all these options. I'm going to disassemble it. I'm going to take the housing, the power supply, and the processor. Now, once again, the housing can be disassembled or reused as it is, or refresh, or shred and recycle, or dispose it as a waste. The same thing with this power supply, and the same thing can be happened for the processor. So every part we have can have multiple options. So just imagine that you have an old laptop and it's done. So you can check, for example, if the bottom of the keyboard can be used on another old laptop to have a new one, then just do it. Or if the charger can be used for another laptop, just keep it. Okay. Or maybe you can use it to turn to run some of LED lights that you can purchase it, but you don't have the adapter for it. So that's about the recycling process. You can disassemble some of the, for example, the vacuum cleaner, the old one. You can disassemble it. You can reuse the cable. You can reuse the motor. You can reuse the speed controller, and you can use the pipes actually to have something else, or you can use the head for a new vacuum cleaner. So all this process is going to be something like an example of the disassembly uh, process for the as a part of the design for the environment. The advanced resources recovery is going to be about we're going to have the part as initial use, second use, and third use. So this will be the primary cascade chain, the third use, then we're going to do recycling to have the initial use once again, or we can send it as a final use. And during that time, we can have a recovery for the part to have a third use or continue it as a new product for initial use and keep repeating this process in a multiple times. So this will be primary cascade chain, and this will be secondary cascade chain for your product. The conditions for the sustainability are first, consider that the Earth is a closed system with a limited solar input and natural biocycles. That's that's the case. That's the real case. The solar energy and the other renewable fuels are sustainable energy sources. They're always going to come to you every day. The resources usage must be balanced to the rate of the Earth creates each resources, even the rate at which the Earth creates the fossil fuel. The toxic wastes, heavy metals, radiation, and the other molecular garbage must be eliminated because they are not part of the biocycle. The challenges we have for the product design for the sustainability are first, eliminate the use of the non-renewable natural resources, including the non-renewable source of the energy. Try to eliminate the disposal of the synthetic and the organic materials that do not decay quickly. Eliminate the creation of the toxic wastes that are not part of the natural life cycles. So now we have to do a life cycle assessment, which is going to be quantifies environmental impact over the product life cycle. The steps we have for the LCA is prepare a proposed design option, identify the life cycle, including recycling and disposal. Third, identify all the materials and the energy sources used in the manufacturing process. Identify the outputs and the waste streams, and then quantify the impacts of each material, energy, and waste, and then aggregate the impact into categories for comparison. This will require a specialized LCA software and training, like for example the CIMA Pro, the GAY, the OpenLCA, and the Sustainable Minds. This is an example of one of the software which you know now as the CIMA Pro LCA software. Unfortunately, this one is not free, but you can find actually some free software for the life cycle assessment. And I think actually the SolidWorks does have a part of the life cycle assessment. We're going to search a video for that. So now the product development process, and let's see how we are going to involve the um, design for the environment. So from the planning, we can simply set the DFE goals and team. In the second and third stage, we can DFE and material guidelines to be added to the concept development and the system level design. The last stage is assess the impacts and refine the designs, and finally improve the DFE process, and then the DFE can be integrated into a standard product development process as we explained here. Now, the major design considerations we have are the functionality and performance of the product must do the job. So the functionality and performance should be done in a good manner. Also, manufacturability and the logistic. So the product can be made technically and feasibly. Reliability and safety, where there must be some of the quality standard. The cost or the market penetrations, where the product needs to be competitively priced. So the DFE process, set the DFE agenda, that's the product planning stage. Second, identify a potential environmental impact and select the material and DFE guidelines, and this will be the concept development stage. Now, in the system level design, apply the DFE guidelines to initial designs. In the detailed design stage, assess the environmental impact, compare the DFE goals. If yes, then go to the next stage. If no, then refine your design and assess the environmental impact again. Finally, if the DFE goals has been passed, you go to the process improvement by reflect the DFE process and the results for your design. Now, the DFE and the material guideline. Example of the DFE guidelines are going to be: do not combine materials incompatible in recycling. So you don't put the metal and the polymers together. Label all the component materials for recycling. Enable the easy disassembly into a separate material recycling streams. Use no surface treatment as much as you can and eliminate the packaging. Finally, reduce the size for the shipping, sorry. Reduce the weight and size for the shipping, because the heavier the product is, the higher energy requirement for the shipping going to be. Now, the example of the material guidelines are going to be: first, use recycled and recyclable industry materials. Use natural materials which can be returned to a biological decay cycles. And use the processes which do not release toxic materials. Finally, capture and reuse all the hazardous materials. The four simple DFE rules are going to be: first, design products and processes with industrial materials that can be recycled continually, with no loss in performance and thereby creating a new industrial materials. Second, design products and processes with natural materials that can be fully returned to the earth's natural cycles and thereby creating a new natural materials. Third, design products and processes that do not produce unnatural toxic materials that cannot be safely proceed by either natural or the industrial cycles. Finally, design products and processes with the clean, renewable resources of the energy rather than the fossil fuel. Now, we're going to look at the levels of the DFE for the automobile parts. First, redesign of the parts, like using the aluminum or the plastic radiator cup, longer lasting tires and batteries, and the aluminum or the steel engines. Second, redesign for the assembly. You can look at the eco-friendly painting or facilitating this assembly and recycling of the plastics. Third, redesign of the automobile itself, like using alternative fuels like the ethanol or the methanol, or alternative powertrains like the hybrids or the fuel cells. Four, redesign of the transportation systems like the smart highways or the public transportation. Fifth, rethinking the need for mobility, like using the virtual office or telecommunicating or the community layout. So this was toward the deep ecology. But if we're going to go backward, this will be toward the shallow redesign. Now, examples of DFE in manufacturing are, for example, we can talk about the BMW and Volkswagen are both using the DFE to study the disassembly and recycling of the recovered materials in the automobiles. Also, Hewlett Packard redesigned some of its inkjet printers under the DFE framework. Sun Microsystems has included a variety of the disassembly features and post-consumer plastics in their products following the implementation of the DFE program. The IBM has incorporated numerous design for the environment features in the series of the computer products. So that's the end of the part 4, and the part 5 is going to be about design for the additive manufacturing.